Welcome to today's video. If you've ever wondered how fluid enters and exits a pump in industrial systems, or what makes pump piping special, this video is for you. We'll break down pump suction piping, straight length, reducers, and the difference between suction and discharge piping, in simple terms. Let's dive in. Pump piping is the network of pipes connected to a pump. One side brings fluid into the pump, called suction, and the other side pushes fluid out, called discharge. The suction line must be designed carefully to maintain smooth flow, prevent cavitation, which can damage the pump, ensure pressure is available at the pump inlet. Straight length means a straight run of pipe before the pump's suction nozzle, with no bends, valves, or fittings. This helps the fluid move smoothly into the pump. Standard rule: keep at least 5 to 10 times the pipe diameter as straight length before the pump. For a 100 mm or 4-inch pipe, 500 mm or 5D of straight pipe should be kept. Sometimes the pipe size doesn't match the pump nozzle. That's where reducers are used. There are two types. Concentric reducer, cone-shaped, center-aligned. Eccentric reducer, flat on one side. On suction lines, we use eccentric reducers with flat side on top to avoid air pockets. Air bubbles can damage the pump. Let's compare suction and discharge sides of the pump. Suction line. Low pressure, high flow. Eccentric reducer with flat on top. Designed for smooth flow, avoiding cavitation. Discharge line. High pressure. Concentric reducer. Can have valves, gauges, and check valves. In short, suction piping needs more care to protect the pump. You may hear about NPSH, net positive suction head. It's a measure of how much pressure is available at the pump inlet. If suction piping is bad, too long, too many bends, wrong reducer, NPSH drops and vapor bubbles form. This is called cavitation, and it damages pump internals. Suction piping do's. Keep the pipe short and straight. Use eccentric reducer flat on top. Maintain straight length, at least 5D. Support pipe without loading the pump. Don'ts. Don't put elbow right before the pump. Don't use concentric reducers on horizontal suction lines. Don't suspend pipe directly from the pump, it causes vibration. Here's a simple layout example. From a storage tank, the fluid goes into the suction pipe, through a Y strainer, then into an eccentric reducer, and finally into the pump's suction nozzle. This layout allows smooth flow into the pump, reduces risk of cavitation, and protects the system. Now you understand the basics of pump piping, especially suction line design. This is the foundation for piping engineering in industries like oil and gas, water treatment, and power plants. If you liked this video, give it a thumbs up and subscribe for more piping design lessons. See you next time.